Hi all, welcome to Chemflix. And in this video, we're going to discuss about the case-based or passage-based integrated questions, mainly for class 10 and term 1 examination. And in this session, we are going to discuss about the first chapter, chemical reactions and combination, chemical reactions and equations, and some of the case-based questions we are going to discuss here. Okay, so without wasting much time, let's go to the video. Okay, the first question is read the given passage and answer the questions based on passage and related studied concepts. We come across many changes around us. Some changes are reversible, that is, no new substance is formed, called physical change, as we all know. And okay, physical change, whereas some are chemical changes. Okay, so you know what is this chemical change and physical changes, right? So if a new substance is formed, then it is called a chemical change, and if there is no new substance, then it is a physical change. Clear? Chemical equation represents the reactants, products, and their physical state. Okay, you know that there you can see some solid in brackets, there you can see some S, aqueous AQ, liquid L, that are all physical states. So chemical equation represents the reactants, products, and their physical state. A chemical equation must be balanced so as to satisfy law of conservation of mass. So law of conservation of mass, in order to satisfy law of conservation of mass, we are balancing the chemical equation. The reactions are classified into combination, decomposition, displacement, double displacement, okay, precipitation, redox, combustion, exothermic, and endothermic reaction. So all you studied in your first chapter. Corrosion is a process in which oxidation or redox reaction is involved. Antioxidants are added to prevent rancidity of food material. So this is a brief idea about what we have studied in the first chapter, that is chemical reactions and equations. So the questions are, so the first question based on this passage. Strong heating of ferrous sulfate leads to the formation of a brown solid and few gases. What type of reaction it is? The question is strong heating of ferrous sulfate. Okay, you're going to heat the ferrous sulfate and it leads to the formation of a brown solid and few gases. So you know that you are taking a single substance, that is ferrous sulfate, and at last the product end products are, what are they? Brown solid and few gases are there. So which is this reaction? What type of reaction is this? Whether it is a combination, decomposition, displacement, double displacement, or what type of reaction? Endothermic, exothermic. So here it is strong heating of ferrous sulfate leads to the formation of brown salt. So if we are giving this system heat. That means if a reaction taking heat, then what type of reaction it is? Of course, it is an endothermic reaction. And the second thing you have to go for it as strong heating of ferrous sulfate leads to the formation of a brown solid and few gases. So here formation of simple compounds results, it is a decomposition reaction. Clear? Formation of a single substance from uh, formation of single substance from a single compound, that is ferrous sulfate. So it is of course an decomposition reaction. So the reaction is what type of reaction it is? It is an endothermic and decomposition reaction. Let's see the reaction, chemical reaction. Here 2FeSO4, when we are providing heat, it decomposes to form Fe2O3, sulfur dioxide and sulfur trioxide. Clear? So here one more reaction that you can see from the chemical reaction, that is in FeSO4, the oxidation state of Fe is +2. Oxidation state is +2. Oxidation state is +2. Okay, but coming to Fe2O3, the oxidation state is +3. So of course this is an oxidation reaction. Okay, so what all are the answers? It is an endothermic reaction, it is a decomposition reaction, and of course it is an oxidation reaction. Clear? Now moving to the next question, that balance the following reaction, that you have to do yourself. What happens when Fe react to the water? You will get Fe3O4 and H2. You have to balance this reaction. and please put that in the comment box so that we can study. Okay. In next question is, in which of the following chemical changes the initial substance remains unchanged? Initial substance remains unchanged means it is a physical change, right? Initial substance remains unchanged means it is a physical change. So the options are curdling of milk, formation of crystals by crystallization, fermentation of grapes, digestion of food. Again, I'm reading the options. Curdling of milk, formation of crystals by crystallization, fermentation of grapes, digestion of food. So here, curdling of milk results in curd, fermentation of grapes results in wine, digestion of food results in what? Energy. So here which one is the physical change? Formation of crystal by crystallization, right? Formation of crystal by crystallization, that is a physical change here. So that means formation of crystals by crystallization, that means this is the substance remains unchanged in its initial substance remains unchanged. Clear? Okay. And the last question of this passage based question, okay, this passage is, what happens when hydrogen sulfide gas is passed through aqueous solution of copper sulfate solution? You know that copper sulfate solution is CuSO4, okay, CuSO4, okay, copper sulfate solution. So what happens when hydrogen sulfide gas is passed through aqueous solution of copper sulfate? So what happens when hydrogen sulfide is passed through aqueous solution of copper sulfate? Okay, write the chemical equation. Let's see. Copper sulfate, CuSO4, that is aqueous, AQ, it is a physical state, representation of a chemical reaction. And when hydrogen sulfide, it is a gas. Hydrogen sulfide is a gas. When it passes through copper sulfate solution, what happens? A double displacement reaction occurs. Here, the sulfur atom attached to the hydrogen sulfide gets displaced towards the copper, and there you can get a black precipitate of copper sulfide plus sulfuric acid. So this is the proper way of representing a chemical equation. There you have to provide the physical state, reactant is there on the left hand side, products are there on the right hand side. Clear? Okay, let's move to the next question. Answer the following questions on the basis of your understanding of the following paragraph and the related studied concepts. Redox reactions involves both oxidation as well as reduction. So redox itself, redox means it is a combination of oxidation and reduction. Okay, redox. If we cut an apple, it turns reddish brown after some time because Fe2 plus present in apple gets converted into Fe3 plus by loss of electrons. Okay, if we cut an apple, it turns reddish brown after some time because Fe2 plus present in the apple gets converted to Fe3 plus by loss of electron. So, loss of electrons means oxidation, right? So, oxidation is a process in which loss of electrons takes place. Oxidation is a process in which a loss of electrons takes place. Oxidation is a process in which a loss of electrons takes place. Clear? Oxidation is carried out with the help of oxidizing agent which can give O2 or remove hydrogen or can gain electrons. So oxidation is carried out with the help of oxidizing agent which can give O2, that means itself gets reduced. Clear? Oxidation is carried out with the help of oxidizing agent. So oxidizing agent, what happens to oxidizing agent? It gets reduced. Non-metals are good oxidizing agents. KMnO4, K2Cr2O7 are also good oxidizing agent in acidic media. Combustion is oxidation reaction. So combustion is an example for oxidation reaction. Reduction involves gain of electron. So coming back to the next one, that is reduction. So reduction, what happens in reduction? Reduction involves gain of electron. If something, for example, here you can see Fe2 plus converts to Fe3 plus. Here what happens? Loss of electron. That's why here the positive sign increases. Here only 2 plus electron. Here 3 plus electron. That means 2 plus changes to 3 plus means 1 electron gets lost. And here what happens? It was gain of electron. If in the opposite case, Fe3 plus Fe3 plus 3 plus changes from 3 plus changes to 2 plus. So what happens here is addition of an electron, right? Addition of an electron. Okay, Fe3 plus 2 plus. addition of an electron. So here in that reaction that reaction can be called as reduction. So reducing agent can add H2 or remove O2 or can lose electrons. Metals are good reducing agent. Reducing agents are used in extraction of metal. So this is just a passage. So now we are going to see which are the different questions that you can expect from this passage. The first question is Fe2O3, which is in the solid form, when it reacts with carbon monoxide, which is a gas, you will get 2Fe, okay, because Fe is solid, plus 3CO2, that is gas. Name the oxidizing and reducing agent in the above reaction. I will give you 2 minutes, no, 1 minute. Please make it fast. Which one is the oxidizing agent and which one is the reducing agent? Which one is the oxidizing agent and which one is the reducing agent? Yeah, so you know that what do you mean by oxidizing agent or what do you mean by reducing agent? So reducing agent helps in the reduction and oxidizing agent helps in the oxidation. So here Fe2O3, it gets converted to Fe, right? Fe2O3 gets converted to Fe. So here what happens? What happens? Here Fe2O3 loss of oxygen. You can see oxygen is removed from Fe, right? So oxygen is removed from Fe means oxygen is removed from Fe means here what happens? Reduction happens. That means here Fe2O3 is the oxidizing agent O A. Fe2O3 is the oxidizing agent. Now look at the carbon monoxide. Here you can see carbon monoxide. What happens to carbon monoxide? Here carbon monoxide. Here you can find that carbon monoxide, that oxygen addition means here what happens? Oxidation happens. Here oxidation happens. Oxidation. That means this is a reducing agent. Which one is reducing agent? Carbon monoxide is a reducing agent. Okay, carbon monoxide is a reducing agent. Clear? Fe2O3 is the oxidizing agent and carbon monoxide is the reducing agent. Agent means the that causes. Okay, agent is the cause. So it is in the reactant side. Clear? Now moving to the next question, that is H2S gas plus Cl2 gas, you will get 2HCl plus S. Name the substance which are getting oxidizing and reduced. Okay, now look at here. Here, H2S. Okay, you can see here H2S, it changes to H2S is in the reactant side and it changes to S in the product side. Okay, so what happens here? Removal of hydrogen. Removal of hydrogen. What do you mean by removal of hydrogen? Removal of hydrogen means oxidation. If it is an oxidation, then which one is a reducing agent? H2S is the reducing agent. Clear? You got the point, right? Reducing agent. Okay. Now we are moving to see what happens to chlorine. Here chlorine, what happens? Addition of hydrogen happens to chlorine. Clear? Here there is single chlorine and in the product side you can see hydrogen is added to chlorine. That means hydrogen addition, which means a reduction. A reduction, if it is a reduction, then chlorine, of course, it is oxidizing agent. Chlorine is the oxidizing agent. Clear? So here the question is, name the substance which are getting oxidized and reduced. So here oxidized is hydrogen sulfide is oxidized to sulfur and chlorine is reduced to hydrogen chloride. Clear? Now we are moving to the third question. Okay. Magnesium plus 2H plus. Here now what happens here? Addition of hydrogen gives Mg2 plus plus H2. So here addition of hydrogen 2H plus means we are adding hydrogen. Okay, we are adding Mg2 plus. Mg2 plus means we are removing 2 electron, right? We are removing 2 electron. So Mg2 plus, okay, what happens to Mg? Mg converted to Mg2 plus and 2H plus becomes H2. So why is magnesium acting as reducing agent and H plus ions are oxidizing agent? So here the question is, why is Mg acting as reducing agent? So here you can see Mg gets oxidized to Mg2 plus. Oxidation means a removal of electron. Here you can see two electrons get removed to form this 2 plus ion. So here Mg is oxidized to Mg2 plus. So here the question is, why is Mg acting as reducing agent, or why is Mg oxidized to Mg2 plus? Clear? So what happens? Mg acts as an reducing agent because Mg loses two electron. Therefore, Mg acts as reducing agent, and H plus ion acts as oxidizing agent because it accepts two electrons. Therefore, H plus ions are oxidizing agent. Clear? And the last question of this session is Cr2O3 plus 2Al gives Al2O3 plus 2Cr. Okay, what are types of the above reaction? So here you can see Cr2O3. Here the O3 is displaced towards aluminium, right? So this is an example for displacement reaction, and of course this is an example for redox reaction. Here you can see aluminium, oxygen is added, and chromium, oxygen is removed. So this is an example for redox reaction, and of course it is an example for right, redox reaction, and it is an example for displacement reaction. Okay, moving to the next slide. That is the next question and the last question of the series. The metal sodium react with the air and water. You know, sodium metal react with air and water. A student reacted sodium with water and measured the volume of gas at intervals of 30 seconds. So the student, suppose it is Vimal who is going to do an experiment, and what he done is he measured the volume of gas at intervals of 30 seconds when sodium is reacted with the water. So he don't know what the gas is. Okay, okay. So the results are shown below. So here you can see this tabular column where time at 0 second you can see the 0 centimeter cube of gas liberated, and 30 seconds 40 centimeter cube of gas liberated, 60 seconds 60 centimeter cube of gas liberated, and so on. This one is 74. Okay, 86, 96, 140. Question number first one, that is a question. At what time rate of reaction was fastest? Rate of reaction becomes fastest. So initially there is, you can see at time 0, you can see the volume of volume of gas liberated is 0, and in 30 seconds, after the completion of 30 seconds, you can see 40 centimeter cube of gas is liberated or evolved, right? So at what time rate of reaction was first? Here 40 plus 20, 60, 60 plus 14, 74, right? So here initially what happens, the first, at what time of reaction it was first? At 30 seconds. Clear? The next question is, name the gas liberated in the above reaction, write the reaction involved. So here all of you please write what happens when sodium reacted with water. What happens when sodium reacted with water? Write the chemical reaction and which gas is liberated. How will you test this gas? You all know that how to test hydrogen gas. Okay, sorry, that gas, how to test the gas. Okay, I will give you a hint, a pop sound. What would be the color of universal indicator when added to solution formed? Okay, you know that when a metal dissolved in water, when a metal dissolved in water, when a metal dissolved in water, what happens? You will get corresponding hydroxide, right? So a metal dissolved in water, you will get a hydroxide. Of course, you know that it is a basic oxide. So what does it show? Universal indicator. What is the color change you can observe when you are adding universal indicator? Which ions are responsible for change in color of universal indicator? So which ion is responsible for change in color of universal indicator? And the last question is, what will be the color of phenolphthalein in the solution formed? What will be the color of phenolphthalein? You know that if it is a basic oxide or basic hydroxide, okay, metal oxides are basic in nature, okay. So here, what would be the color of phenolphthalein in the solution? You know, in acidic phenolphthalein is colorless, and in basic phenolphthalein shows pink color. So you have to find out the color of phenolphthalein if you are adding this phenolphthalein to that solution form. Okay. So this is all of this is my intention is that I just want to introduce the passage based questions to you guys, so make it useful, and also please subscribe to my channel, and if you like this video, click on the like button, and also please share among your friends. Thank you all, thank you.